Sorry for the skip. Had to delete that problem. So 5, fill in the unit circle and use it to evaluate the expressions listed below it. So right here, I would practice filling in your unit circle by yourself. Those are the values. You can pause here if you need that. But you got to be able to know this from memory because you need it to evaluate some of these values. So draw your unit circle really quick, and then let's do these. Okay, welcome back. Let's do sine of 5 pi over 3. So I go to 5 pi over 3 here. And sine is my y coordinate at 5 pi over 3. So sine here will be negative square root of 3 over 2. Now for this part, I'm going to do cosine of 3 pi over 4. 3 pi over 4 is here, and 3 pi over 4 has a negative x coordinate because I'm in quadrant 2. Cosine is x, so negative square root of 2 over 2. And then sine of 19 pi over 6. Okay, there are 2 ways you can do this. So you can count by the pi over 6s until you get to 19. Remember, like, all of these that I'm highlighting are the different 6s, right? Like my 6, 3, 2s, and then my like different corners are all of my pi over 6s. So let's count by those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So this is the same thing as sine of 7 pi over 6, which is the y value at 7 pi over 6. Sorry, oops. Which is negative 1/2. And also remember, you could break this apart kind of like what we did on number 1 and 2. You can break it apart with the period. Just rewrite your period as a fraction, because remember the period of the unit circle is 2 pi. So I could rewrite this as sine of plus my period, and if I want my period to be over 6, I can rewrite 2 pi as 12 pi over 6. That goes into it one time, and I've 7 plus 12 gives me 19. So that's how I could also know it is 7 pi over 6. Same thing with my pi over 2s. I can count. Let's do that. It's just my halfway points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So this is the same thing. Let me change it to yellow as pi over 2. Oh, and I forgot to highlight this one to match. So if I'm looking at this, it's the same thing as cosine of pi over 2, which is the x coordinate there, which is 0. And remember, if I want to break this apart the math way, I could write this as plus 4 pi over 2. 4 goes into 17 4 times, and I've got a remainder of 1. Here, find the period, amplitude, and frequency, and midline here. Let's go ahead and do that. My period is how long it takes to do the full cycle and end up where I was. So for the period, I go down, up, and end up back at the top here. Ooh, I want it to be wavy. So it takes, my period is pi, max to max is pi. And remember, frequency is 1 over period, or frequency is just flipping my period. If I think of this as pi over 1, I can flip this to 1 over pi. My midline is halfway between a max and min. So my max is 4, my min is -8. So I could, and remember midline, it has to have y equals. So I could do 4 plus -8 over 2. That'll give me the halfway point, which is -4 over 2, which is -2. Y equals -2. And my amplitude here is, if my midline is here, my midline, my amplitude is found from going from my midline to the max or min. The distance from my midline to here is 6. One more. Actually, yeah, we'll do one more on this function, on this problem. So the sinusoidal function n of theta has a maximum at the point -2, 10. The next minimum is at pi, comma, -2. And then it wants me to find the 3 different things. So I like to draw these. You do not have to by any means. And notice I'm starting over at a negative, so I do need to draw like a more of a full quadrant here. 4-coordinate grid, sorry. So we'll say -2 pi is about right here. It doesn't have to be perfect. This just helps me visualize it. So I have a maximum point here at 10. Okay. I have a maximum point here at 10. So I'm going to draw that point. And then I have a minimum at pi, comma, -2. We'll say pi is like right here. Maybe a little closer in. Pi is right here. And -2 is right below it. This just helps me visualize it, definitely not drawn to scale. Okay, and what I can see is I went from a max to a min. I went max to a min. So I went half a period, because a full period would be max to max. And this distance, that I've went so far is 3 pi. So the full period would be another 3 pi, so, which is 6 pi total. So my period is 6 pi. Remember, my frequency is just 1 over my period, or my period flips, so 1 over 6 pi. And then I need to find my midline next. And remember, it's always going to be y equals something, my max and my min. My max plus my min over 2. It's halfway between it, so 10 plus -2 over 2. And that will give me y equals 4. So the distance between my midline and my max or min is 6. So my amplitude is 6. I promise the amplitude would not always be 6, but it was in this case.